Write the expression for the reaction quotient, QC for the given gas phase equilibrium system. H2 plus I2 is an equilibrium with 2HI the reaction quotient, which measures the relative amounts of products and reactants at any given point in time, is written as QC equals HI to the power 2 over H2, I2, define the initial concentrations of the gases. The problem states that equimolar samples of H2, I2, and HI are introduced into a 3.0 liters container. Equimolar means that the same number of moles, N, of each gas is initially present. Since all three gases occupy the same volume, their initial molar concentrations must be identical. H20 equals I20 equals HI0 equals XM. Calculate the initial value of QC. Substitute the identical initial concentrations, X, into the reaction quotient expression, QC equals X to the power 2 over X. X equals X to the power 2 over X to the power 2 is equal to 1 because the concentration terms cancel out mathematically. The initial value of QC is exactly 1, regardless of the specific number of moles added or the volume of the vessel. Compare QC to the equilibrium constant. Kc, we are given that the equilibrium constant is Kc equals 50 at 600 degrees Celsius. Comparing our calculated value to the equilibrium constant, Qc equals 1 quad and quad Kc equals 50. Therefore, Qc less than Kc determine the direction of the equilibrium shift. Because Qc less than Kc, the ratio of product concentration to reactant concentrations is smaller than it needs to be to achieve dynamic equilibrium. To reach equilibrium, the system must shift its position to the right, favoring the forward reaction, to convert reactants into products. This forward shift will consume the reactants, H2 and I2, and produce more of the product, HI, until the reaction quotient rises to equal the equilibrium constant of 50. This matches option C. The correct answer is option C. More HI will be produced because Q less than Kc.